And hello, and I apologize again for my asthma attack. I ended up having to take an antihistamine and going to bed, so I was not able to get back to these until this morning. So here we are on page 19 of the notes. So just want to hit a couple of these review factoring problems before we get to the new stuff. The new stuff only has one new thing, and we're learning how to solve equations once we've factored things. So there's going to be lots of factoring practice when we are working on this last section of solving equations. So looking first at, we'll do this one here on the left, and make sure that you get it first into descending order. So y squared minus 2y plus 1. And then I'm going to check for a greatest common factor. There is not a greatest common factor other than 1. So I am good for that. Now, this is one where you might not think automatically, oh, hey, that might be a perfect square trinomial. Because sometimes we overlook y squared or x squared and 1. But those are both perfect squares also. So if you check and you look at what is the square root of each of these, so the square roots are being y and 1, and we would want to multiply those together and then double, so multiply by 2, to get my middle term. So 1y times 2, 2y. So yeah, that does match. This will be a perfect trinomial, perfect square trinomial situation. So I can take those two pieces then, and I know that that's going to be that binomial squared, and then I grab the operation from in front of the middle term. And remember, if you're not sure, multiply these things back out. Now be careful, because it's not equal to y squared minus 1. You remember, you have to think about it as foiling this out. Okay, so make sure that you are thinking through that when you are multiplying back through. We cannot distribute this squaring over addition or subtraction. We can over multiplication or division, but not addition or subtraction. We have to deal with the factor as a whole. All right, let's see, the next one here. So 4y squared plus 20y plus 9. All right, so those are ones that I do suspect are perfect squares. So that's 2y, and that is 3 if I take the square roots. Now multiply these together, we would get 6y, but then we have to multiply by 2. So for this to be a perfect square trinomial, I'd be looking for 12y as my middle term. So this is not a perfect square trinomial. At which point we need to use the AC method, and we can do some factoring by grouping. All right, so A here is going to be 4, our y squared coefficient. C is our constant, 9. So 36 is what we are factoring. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. So to get 20 as my middle term, so which one is going to give me that? That would be the 2 and the 18, and if I add those in there. So instead of the 20y, we are going to put 2y and 18y. So these still add to the 20y that we had in the original equation, the original polynomial that we're factoring. And now I have forced a 4-term situation. So we always look, is there a greatest common factor for all of them? No, there wasn't when we started with the trinomial either. And that means we're going to then look at factoring by grouping. So group those two pairs of factors. and then see what we can factor out. Now we can pull out a greatest common factor if we're just focused in on each pair. So this pair, 2y, can be factored out, leaving behind 2y plus 1. And in the second one, we can factor out a 9, leaving a 2y plus 1. And so that is good because we hope will happen when we are factoring by grouping has happened. We got a common binomial. So to continue on, we're going to factor out the entire binomial, and then the leftovers, remember, go in the second set of parentheses. So that is going to be our finally factored answer. And remember, you can always FOIL and double check. Make sure that you get back to that 4y squared plus 20 plus 9. FOIL to check. So take the time to do that because there's not going to be a lot of opportunity for me to give partial credit on things. So try to head off any possible mistakes before they happen. All right, the 4x squared plus x plus 9. All right, so that is looking quite a bit like the one that we just looked at. And when we checked that one, we said that that middle term that we would be looking for to get a perfect square trinomial would be 12y. All right, so this is still, it's not 12x. So we're still looking at using the AC method and looking at factoring 36 again. All right, I'm just going to repeat it over here so that it's in camera range, even though we just did it over here. So you don't necessarily have to do it twice. I just want to make sure you can see it and I can point at it. All right, so which pair would add or subtract to 1 for our middle coefficient? Now we have to be careful here because we're actually not going to have anything that would add or subtract to 1. So remember, thinking through each of these pairs, they're either going to add to 37 or subtract to 35. 2 and 18 would either give us 20 or 16. 3 and 12 could give us 15 or 9. The 4 and the 9 would get us either 13 or 5. And then the 6 and 6 is either going to give us 12 or 0. So none of those is matching with this 1 that I have as a coefficient for x. And this is the sum total of possibilities for factoring this. There isn't anything else over the real numbers. Now, when I say over the real numbers, I mean things that don't have an I. The imaginary numbers, which you may have seen in a previous math class, we're not dealing with those right now, and they're not part of Math 40. So, since we can eliminate those from our concerns here, and we don't have anything here that's going to work, I can come to the conclusion that this one is prime. So there is not a way for me to factor this with real numbers. And specifically I'm looking at integers, but in this case it would be a real number situation as well. So I would have to stop there, and I would just have to say it's not factorable. So not factorable would be another way to say that. All right, so that finishes us up on page 19, since we did the very final one we did together in class yesterday before I couldn't stop coughing. All right, so solving equations. So we have been doing a lot of work with expressions, and we've been doing work with solving equations when we have been writing equations and then solving them. Here we're going to look at dealing with quadratic equations. And I told you at the end of 38, you guys were great with any first degree equation. Anything where we had no variable that had a power greater than 1. So here is where we get to start doing equations that have a power of 2. So quadratic equation. And that is in this standard form. So you should recognize this from looking at the factoring last section. And we are going to be looking at how we can then solve those equations. And we're going to be specifically looking at using factoring. So if we had a situation where something is not factorable, like we did on the very last example, we wouldn't be able to go any further with that in this class. When you get onto Math 100, then you're going to start talking about, okay, well, what happens when I can't factor it? What do I need to look at in my tool bag at that point? So factoring is going to be our main method here. So make sure you're practicing your factoring enough that you're starting to anticipate how things happen, and then you can be prepared for any of the little snares that the math textbook writers like to stick in there. So notice that a can't be 0. If that coefficient of x squared was 0, then this would become a linear equation. It's not a quadratic equation anymore because it only has an exponent of 1. Now, this was something I had to look up because I was like, I've always wondered why are quadratic equations called quadratic? Okay, so it involves a square, but not the 4th power. So quad, quadrilateral is a 4-sided figure. Now, some of you guys have quads. They have 4 wheels. Why is this not a power of 4 situation? And it's because it actually comes from a Latin word. So it's coming from quadratus, which means square. So it's coming from one of those old Latin roots of quadrilateral. So it's which is why it's going to be a 4-sided figure in this, when it's an actual figure of a square. But in this situation, it is going to be the power of a square. So the power of a square. If we don't have that squared power there, it's not a quadratic. All right, so our zero product rule we talked about before, and definitely in 38, if you had that with me, or in a previous math class that you've had at some point. When we multiply 2 real numbers and we get 0, at least one of them is 0. And it just has to be that way. There's nothing that I can multiply to any other 2 numbers that I can multiply together where I would get a product of 0. So I can't be like, oh yeah, 2 times 3 is 0. No. There isn't anything else. I could say 2 times 0 is 0, and 3 times 0 is 0, but there's no other pair of numbers that I'm going to come up with when I multiply them that's going to be equal to 0. And it's important to know that because that logic is how we are going to be able to solve these quadratic equations. So if this is the case, so in symbols here, this is what's happening. A and B are elements of the real numbers. So that funny R stands for the set of real numbers. And if A times B is 0, then either A equals 0 or B equals 0, or both are equal to 0. So we are going to end up with 2 possible answers, and we can use our factoring to factor our quadratic equation that we have. Make sure that it's set equal to 0, and then we can set each of those pieces equal to 0. Because if the 2 pieces multiply to 0, then one piece or the other piece, or both of them, have to be equal to 0. So in this one, it's a little bit more challenging factoring situation, so it's already factored for you. So what we're looking at here is, I've got 5x squared and 72, so I've got to make sure I get 5x squared, and, you can double check by foiling to make sure that this is factored properly. But basically I'm saying, here's A times B, and they've got to equal 0. So either this one is equal to 0 or this one is equal to 0. So when we hit this point, we then split into 2 equations. And I'm going to pause here because I'm running out of room on my video.